My name is Lok Jain, number metric 298202. Now I would like to discuss the question 1. Question 1a. What is the difference between a null hypothesis and an alternative hypothesis? First, we need to understand the both terms. A null hypothesis is a statement about the value of a population parameter developed for the purpose of testing numerical evidence. However, an alternative hypothesis is a statement that is accepted if the sample data provides sufficient evidence that the null hypothesis is false. Next, what is it? A null hypothesis is what the researcher tries to disprove, whereas an alternative hypothesis is what the researcher wants to prove. Moreover, a null hypothesis represents no observed effects, while an alternative hypothesis reflects some observed effect. The fourth difference between the both hypotheses are acceptance. If the null hypothesis is accepted, no changes will be made in the opinions. Conversely, if the alternative hypothesis is accepted, it will result in changes of the opinions. Question 1b. What is the difference between a one-two test and two-two test? One-two test is a statistical hypothesis test in which alternative hypothesis has only one end. However, a two-two test is a significance test in which alternative hypothesis has two ends. Next, the region of rejection in one-two test is either on the right or on the left. But the rejection area in two-two test is on the both sides. A one-two test or what is also called a directional test is either the right tail and the left tail test, while a two-tail test is called non-directional test. It means the right tail and the left tail at the same time. Additionally, the risk of making type 1 errors is more in the one-tail test because the statistical significance level is associated with only one tail on one side of the probability distribution. On the other hand, the risk of making type 1 error is less in the two-tail test because the value of alpha is divided into two directions. Question 1c. What is meant by a p-value? The p-value is defined as the probability under the assumption of no effect. This assumption is known as the null hypothesis. The p-value measures the probability of obtaining result equal to or more extreme than what is actually observed. Question 1d. Step 1. We need to state the null and alternative hypothesis. We can see that the last sentence on this question is asked about the average weight at birth will change or not. So, our alternative hypothesis is mu not equal to 6.6. Then the null hypothesis is naturally equal to 6.6. Step 2. We need to select the level of significance. So, the level of significance on this question is 5%, which is alpha equal to 0.05. Step 3. We need to determine the appropriate test statistic. We will use t-distribution on this question, as delta is unknown. Step 4. We need to draw a graph. This graph will show the rejection region for a two-tail test. The null hypothesis is rejected if the calculated t-value is greater than 2.447 or less than negative 2.447. The two-tail regions each represents 0.025 of the entire distribution, which is 0.05 for the rejection area. Step 5. We need to compute the value of t and make a decision. The formula for the t-distribution is the sample mean minus the population mean divided by the sample standard deviation over the square root of the sample size. So we can get the value 2.151. Conclusion: 2.151 falls outside the rejection area. Do not reject H0. We conclude that there is no change in average weight at birth.
My name is Lim Zing and my metric number is 298338. For question 2a, list the 5 steps to perform hypothesis testing. So, step 1 is state the null hypothesis and alternate hypothesis. Step 2 is select the level of significance known as alpha, which is the probability of rejecting the null hypothesis. Step 3 is select the test statistic. Common test statistics include Z-test and T-test. Step 4 is formulate the decision rule. Last step, which is step 5, is make a decision either we reject or do not reject the null hypothesis, H0, and interpret the result. For question 2b, we gather the information from the question. The mu is 19 days, the mean is 94 days, sample is 100, standard deviation is 22, and the significant level, which is alpha, is 0.1. After gather the information, we can start to do the 5-step hypothesis testing. Step 1 is state the null hypothesis and alternate hypothesis. So the keywords here is an increase in sealing time. So our alternate hypothesis is mu more than 19. Our null hypothesis is mu less than equal 19. Step 2 is select the significant level, which is alpha equal to 0.1. Step 3 is decide the test statistic. So here we use t-distribution since the sigma is unknown. Step 4 is formulate the decisions. We can draw the one-tail graph and shade it on the right tail to show the rejection area. After that, we refer the t-table. We look the level of significance 0.1 intersect with degrees of freedom, which is 99. So you can see that they intersect at 1.290. Then we can reject H0 if computed t bigger than 1.290. Step 5. Make the decisions and interpret the result. We need to determine the value of t by using the t formula. After we calculate, we get the value of t is 1.818. The 1.818 is larger than 1.290. So the final answer is 1.818 falls inside the rejection area. H0 is rejected. We conclude that the mean sealing time of farm properties has increased at the 0.1 significant level. For question 2c, also use the 5-step hypothesis testing. Step 1, the keywords in the question state that the mean salary are greater for the fast food workers than the restaurant worker. We write the alternate hypothesis is mu for the fast food workers, mu f, larger than the mu for the restaurant workers, mu r. The null hypothesis is mu f less than equal to mu r. Step 2, alpha equals to 0.1. Step 3, use t-distribution since sigma is unknown. Step 4, draw the one-tail graph and shade it on the right tail to show the rejection area. We look the level of significance 0.1 intersect with the degrees of freedom, which is 11. So you can see that they intersect at 1.363. For step 5, we have to calculate the pool sample standard deviations. So first, we must calculate the sample standard deviation and the x-bar for both samples by using scientific calculator. Then we substitute the sample standard deviations and x-bar for both samples into the pool t-test formula. After calculate, we will get answer for pool sample standard deviations equal to 204.075. Next, we determine the value of t by using the t formula. So we substitute the number and we'll get the answer equal 1.537. So the final answer is 1.537 falls inside the rejection area. H0 is rejected. We conclude that the mean salary are greater for the fast food workers than the restaurant workers. The question also asks for the p-value. How to get p-value? Since the t-value is calculated which is equal to 1.537, the degrees of freedom is 6 plus 7 minus 2 equal 11. The significant level is 0.1 one-tail test. So refer back to the t-table. Look at the degrees of freedom, which is 11. We found out that the t-value 1.537 is between 1.363 and 1.796. Look at the level of significant value for one-tail test. We can conclude that the p-value is between 0.05 up to 0.1.
My name is Wang Wenxi. My matrix number is 298333. Now I will explain the answer of question 3a. First, the question already given the sample size which are 7 for each training survey, and this show that it is a dependent sample. To answer this question, we can use the 5-step hypothesis testing. Step 1, alternate hypothesis which is mean difference not equal to 0, and null hypothesis which is mean difference equal to 0. This is because the last sentence states that the hypothesis that the training was effective in improving customer relationship. Means has effect on customer relationships, so alternate hypothesis is mean different not equal to 0. Step 2 is the level of significance equal to 0.05. Step 3 is using t-test. Step 4 is using the t-distribution table to determine critical value of t. Since degree of freedom equal to 6, which is 7 minus 1, level of significance equal to 0.05, and it is 2 t-test, so the critical value of t equal to negative 2.447 or 2.447. Step 5 is using the formula means difference divide by standard deviation of the differences per square root sample size to find computed t, which is 2.542. In conclusion, 2.542 falls inside the rejection area. No hypothesis is rejected. We conclude that the training was effective in improving customer relationship. This slide, I will explain the answer of question 3b. To complete the ANOVA table, we can use the provided information such as SS total, which is 500, degree of freedom for treatments, which is 2, degree of freedom for total, which is 11, and mean square error, which is 20. Substitute them into the formulas. Then we can obtain K equal to 3, N equal to 12, degree of freedom for error equal to 9, SSE equal to 180, SST equal to 320, mean square treatment equal to 160, and computed F equal to 8. For question A, there are 3 treatments because K equal to 3. For question B, total sample size equal to 12 because N minus 1 equal to 11. For question C, since level of significance equal to 0.05, degree of freedom for numerator equal to 2, and degree of freedom for denominator equal to 9, we can obtain critical value of F equal to 4.26 based on F distribution table. For question D, null hypothesis which is mu1 equal to mu2 equal to mu3, and alternate hypothesis which is the means are not all equal. This is because K equal to 3 and this is using F statistic test. For question E, since computed F is larger than critical F, in conclusion, it falls inside the rejection area. No hypothesis is rejected. We conclude that the means are not all equal. This slide, I will explain the answer of question 3c. The question already given 3 different airlines, which is K equal to 3, and this show that it used F statistic test. To answer this question, we can use the 5-step hypothesis testing. Step 1, alternate hypothesis, which is the means are not all equal, and null hypothesis, which is mu G equal to mu J equal to mu C. Step 2 is the level of significance equal to 0.05. Step 3 is using F statistic test. Step 4 is using the F distribution table to determine critical F. Since level of significance equal to 0.05, degree of freedom for numerator equal to 2 and degree of freedom for denominator equal to 32, we can obtain critical value of F equal to 3.32. Step 5 is using formulas to find the sample mean for treatment C, which is 50.5, 52.07, and 55.71. Gram mean, which is 52.17, SS total, which is 796.97, SSE, which is 669.86, and SST, which is 127.11. Next, we can complete the ANOVA table based on the formulas. Since computed F is smaller than the critical F, in conclusion, 3.04 falls outside the rejection area. No hypothesis is not rejected. We conclude that there is no difference in the mean 5 times among the 3 airlines.